Hello everybody, a very warm welcome to our next session. This is optics and lighting. Because we are a little bit in time pressure, let's start immediately, and I want to welcome warmly our first speaker, Francesco Mondadori from Opto Engineering, and he will talk about new 360-degree view optics for cavity inspection. So please, the stage is yours.
Great. Thank you very much for your introduction. And yes, I am Francesco Mondadori, and I am a product manager for Opto Engineering, where I take care of the optics and cameras. And in this presentation, yes, I will be presenting you the new 360-degree view optics for cavity inspection. But before, let me just briefly introduce you my company in case you're not familiar with us. Opto Engineering is a company based in Italy that designs, manufactures, and markets imaging components. In fact, starting from what was and still is our core business, that is telecentric lenses, we progressively expanded our range, becoming basically a provider of almost any kind of machine vision components, ranging from several types of optics, lighting solutions, cameras, software tools, all the related accessories, including strobe controllers, cables, and so on, AI vision units as well, and last but not least, also machine vision kits that are particularly meant for laboratories, to equip machine vision laboratories. So in order to, let's say, better comprehend and understand the topic of the presentation, let me just briefly give you an overview of the main types of optics that are employed in machine vision. Starting from those that are known as entrocentric lenses, and this is basically a complicated term to say that they work like our own eyes do. So they are designed to accept rays that are diverging, from the optical axis. One of the main drawbacks of such kind of lenses is that, as you experience every day with your own eyes, objects that are closer to you appear to be bigger than the ones that are placed far away. So in order to overcome this, let's say, limitation, that can be a problem, especially when you're dealing with measurements, there is another important type of optics that is commonly employed in machine vision, and they are telecentric lenses. This kind of lenses is designed to accept only rays that are parallel to the optical axis. And let's say the advantage of such an optical design is that basically objects maintain their dimensions no matter where they are in front of the lens. So even though they are at different distances, let's say the same object will appear with the same dimension. And then there is a third type of optics, which is basically the core of this presentation, that is represented by 360-degree view lenses. These lenses are designed to perform an all-round check of the objects with just one image, so with just one camera. And we can further divide these optics into three main groups. We have outer inspection lenses to capture the top and side of the object. And in the upper part of the slide, you can see a typical optical design which is employed for these lenses that is called pericentric, meaning that the rays in this case are converging instead of diverging. Then we have a second group, which is represented by inner inspection lenses, meant to capture the bottom and sides of the object. And finally, we have multi-mirror lenses that, as the name suggests, exploit multiple mirrors or arrays of mirrors in order to get multiple images of the same object at different angles. But now, let's come to the nitty-gritty of the presentation, and so 360-degree view lenses for cavity inspection. As you can imagine, these lenses belong to the second group that I just mentioned, so inner inspection lenses. And it's safe to say that cavity inspection is a very transversal application because it is common to many fields, many sectors, including, but not only automotive, beverage, but also the pharmaceutical one. And here I reported just 3 simple examples of objects that are inspected with such lenses. The main advantage that I already mentioned before of 360-degree view lenses is that they are designed to acquire a single image, so using a single camera. And this is very important when you compare them with more traditional solutions such as multi-camera systems. In fact, in this table you can see, let's say, a quick comparison between the two possibilities. And even though both the two approaches are suitable for inline applications and they both grant high throughputs, let's say that similarities hand here. Because 360-degree view optics are meant to use a single camera. That means that the system is way more compact. It's suitable also for small fields of view, something which is not so simple with multi-camera systems. The setup of the system is way easier with, of course, a single camera. And also the post-processing, so the software analysis and the image processing subsequent to the acquisition is way easier if you have to deal with just one image instead of multiple images. And last but not least, 360-degree view optics are basically a general purpose hardware. So let's say when compared to multi-camera system, they can be basically adapted to different types of applications, while multi-camera systems are generally specifically tailored for a given task, let's say. The first type of inner inspection lenses is represented by PCBP series, which is that features borescopic probes. So these optics are meant to acquire the sides of the object when they are inserted inside the cavity. Here you can see basically a scheme of the working principle of these optics that explains better than any word what I meant before. So the probe is inserted inside the cavity and you have a circular crown around the lens that images the sides of the object. Not only because these lenses feature an integrated illumination, so there's no need for an external source, making them extremely compact and easy to handle as well. One of the main drawbacks, however, of these optics was, I must say, that they were not suitable for very small cavities. In fact, with, let's say, the standard design, you couldn't go lower than 25 millimeters, more or less. But recent advances allowed to basically shrink a lot the dimensions of the optics, and so now it is possible to inspect diameters down to 5.5 millimeters or so. In the picture, you can see the comparison between, let's say, the older standard version and the newer, smaller one, and it's pretty. I mean, it's pretty clear that there was a significant step forward in this sense. In the table, I reported the typical range of diameters that can be inspected with these lenses. Diameters that range from 5.5 to 100 millimeters, more or less, and of course the height of the sites that you can inspect change accordingly. In most cases, endoscopic probes are usually handled by sclera, or more generally by robotic arms, as of course they need to be inserted into the cavity. So typically some kind of handling system is needed with these lenses. And here you can see a scheme of the two versions, the one with the integrated illumination and the one without the integrated illumination, handled by robotic arms to inspect different cavities. There is also a second type of inner inspection lenses represented by our PCHI series. In this case, let's say the approach is slightly different because these optics are designed to acquire a curved field of view, as you can see in the scheme on the right side of the slide. So instead of acquiring a flat field of view, as basically standard optics do, they acquire a curved one, allowing you to inspect the bottom and inner sides of the cavities without introducing the lens in this case. The range of possible diameters is reported here, and it goes from 10 to 120 millimeters, more or less, while the height of the sites that you can inspect depends on the resolution, of course, that you are requiring from the lens. There is also this R factor, which is basically the ratio between the bottom and sides in the image. So the higher this ratio, the higher basically the sides compared to the bottom that you're imaging. Due to this wide variety of possible diameters, these lenses are extremely versatile. And here I reported just a couple of examples of samples that are typically inspected with these lenses. Millet parts, commonly employed in the automotive field, or vials, commonly used in the pharmaceutical industry. But also for these lenses, there were very important and significant advances recently, because one of the main, let's say, innovations that we achieved was the integration of liquid lenses. Liquid lenses basically allows you to change the working distance of the lens, so you can refocus the lens at a different distance, the different working distance. For normal lenses, this is extremely interesting, but for such kind of lenses, this is even more significant, because basically when you change the working distance, you also change the shape of the field of view that you are acquiring, meaning that you can adapt the lens to the sample that you are inspecting, or to the object more in general that you're inspecting. And this, of course, brings a lot of advantages when compared to, let's say, mechanical or manual approach. That is, it is way faster and way more reliable. It is possible to control anything remotely, so using a PC. And it is also possible to synchronize the refocusing, meaning that if you have a changeover during your application, you can synchronize the acquisition with the refocusing in order to have any detail in perfect focus, basically. Here you can see a simple scheme of the working principle of the refocusing mechanism. So changing the working distance, you can change the actual field of view of the lens, allowing you to acquire different samples with a very fast refocusing mechanism. Another important thing is that due to the fact that these lenses are not meant to be introduced inside the object, you don't necessarily need basically a robotic arm to handle them. You can simply place the samples on a conveyor belt or a rotary table, and the lens can be fixed upon them, basically. So that's pretty much it from my side. Here you can see my contacts. If you want to reach out, I will be more than happy to interact with you. We also have a stand at booth D48. So if you are interested, we are also exhibiting these products that I just discussed. So feel free to pass by and ask to our guys to show you a live demo of what these products are capable of. And yes, without further ado, Q&A time, if we have enough time.
Yeah, first of all,
thanks.
Thanks a lot, Francesco, for this great presentation and really a great overview. And well, it seems that your presentation were very clear, and this was for me, so I don't find questions from the audience. And yeah, I think we can use the safe time to go ahead into
Okay, that's great. So,
or is there an analog question from the audience? No.
Great. Thank you very much.
Thank you.